Okay, great. Hey everyone. Let's see. This is mev-boost community call number 8. I'll drop the agenda here in the chat, and yeah, let's just jump into things. So first, we'll start with the neb. On the spec front, there's version 4 of the builder specs, which should cover all the neb changes and should be ready to go for that. I think at least the Flashbot software is ready and implements that. With mev-boost relay, that's version 029. There might be a version 0291. Let's see, Chris, do you mind giving an update on the status of the Flashbot software for Deneb?
Yeah, for sure. On mev-boost is then ready with the v1.7 alpha 1 release. Let me post a link here. It's an alpha release because we did want to get Kiln or Lido to test it on mainnet before taking a proper release. But this alpha release has been running through the last couple of testnets. And this week there is another shadow fork. And once that is all successfully concluded, we are going to cut a 1.7 release of mev-boost end of this week or early next week. The relay is ready with the v029.1 release. Oh, okay, it's broken. That is correct, it's a draft release, but you can find the Docker images and everything. Let me find it here because I think, yes, one issue that has all the links about the releases here on mev-boost.
Yeah, the link worked for me. But yeah, this one, yeah, I think, let's see. Oh, okay, maybe this is the right one.
Yeah, at the end. Oh, thanks, Sarah. Yeah, I posted the wrong link, I think. So yeah, mev-boost, alpha release, stable, and gonna cut the full release probably early next week. And on the relay, we are on the v029.1 release, the latest proper release. We did release v029 recently, and shout out to Alex from Ultrasound, noticed an issue with the publish endpoint version 1 versus version 2, an environment variable that was wrongly used. So we did this patch release 029.1 that fixes that. And this is the release we are expecting to keep around for the whole DNAP merge. There is no changes necessary at this point from our end.
Okay, great. So if you're listening and you run mev-boost, you'll need to update to this new release. It'll be version 1.7, it sounds like. I think that'll be ready, it sounds like, within the next 7 days, at least by the end of next week. So that's great. And also, if you're listening and run a relay, you probably in some way use this mev-boost relay software. So definitely be aware of that and go ahead and make the changes you need to make. Deneb has been scheduled.
Maybe one more addition.
Oh yeah.
Sorry, one more addition was that the builder is running our reference builder is running on the Deneb branch with the latest tag being with the latest release being this one. So if anybody's interested in the builder code, this is the one that we've been using. There is still a small issue about calculating an invalid Merkle root at some in some situation we are investigating. That's not yet fully fleshed out. That's
okay. Is that related to blobs or something else?
Yeah, exactly. That has the DNAP changes as well. And the submission
but
changes.
the Merkleization bug that you were just mentioning, is that with blobs or some other change?
Let me ask Sarah. Do you have a bit more details here?
I'm not sure if it's related to blobs. I definitely related to Denkun. So after the Denkun fork, sometimes in the testnet it will see this error, and then so it will make the basically sometimes in the testnets we see like the beacon getting out of sync. So not sure if it's like blob related, but it's definitely like Denkun related. Because I only see this like after the Denkun fork.
Yeah. Okay, cool. Great. So yeah, I think even if you don't directly use the mev-boost relay software, you probably use Flashbots Builder to validate your payloads. So thanks for bringing that up. Another piece of software to keep track of. And what I was just saying, the main Denkun fork has been scheduled. I believe it's March 13th. So yeah, now's the time to start getting ready, and hopefully it all goes smoothly. And great. Okay. Let's see. We could touch on testing. I don't know if anyone here has been looking at that lately. But yeah, I know that we've been testing on the shadow forks and things, versions of mev-boost, like Chris mentioned. So yeah, hopefully that's all ready to go. And definitely in the next few weeks, this is something we can drill into. So cool. Anyone have any questions on that stuff right now? Okay, yeah, good idea, Chris. Any relays other than flashbots? Want to give an update? Maybe just act that you're aware this is happening and you need to update your software. Okay, we got acknowledgement from Bloxroute and ultrasound in the chat.
Good question. Do we know when Gorley is going offline?
Yeah, I don't know if there's like necessarily an official deprecation date, but I know like Lido has started even telling people to spin things down. I can go find if there is anything, but ultimately I think it's up to you if you want to drop support.
Cool. Yeah, we have so many validators that are only using Gorley. No one's on Haleski yet, so we're trying to encourage people to switch to using our Haleski relay instead of our Gorley relay.
Yes, definitely stop doing that. Or sorry, start doing that. Christine
no.
thinks
What
she
did I
says
do?
April 13th. So yeah, but generally the idea is like Gorley is deprecating or has been deprecated. So people can keep running Gorley as long as they want. I think a lot of the stake will go offline in the next couple of months. And that will be that. So definitely push people to use Haleski would be, I think, the right test net. So another thing to start doing. And Chris has an ask. Very good. Just have people online and watching. This is a good question. I think generally the consensus clients will not use mev-boost like an epoch or so around the fork. That's something I can double check. But that all being said, if something is an issue and goes wrong, it might be the case that we need to like turn your relay off to sort of limit, bugs and or damage. So please be handy for that. Okay. Are we all ready for Dinkum? Hopefully we will be. Cool. So another thing I wanted to bring up was a number of different discussion points. The first one hopefully is pretty straightforward. I put together this proposal to change how we do block scoring. So maybe I'll even actually share my screen and just run through this. Let me try this. Can everyone see this?
Yep.
Okay, thanks. Right. So pretty straightforward. The proposal is to make sure that when a builder submission comes to the relay, it's not including withdrawals. Yeah, I mean, just to like give some quick context, essentially, one way that many relays are computing a block's value is by just looking at the fee recipients ETH balance before and after the payload. Pretty straightforward. The way that withdrawals are processed, it turns out that basically if there's like, especially when they're like large withdrawals to the same fee recipient as the one the builder intends to pay, you can get to a place where this withdrawal amount is counted towards like the MEV in the block, which, you know, I think this is essentially just a quirk of the way these things are handled, and ultimately it causes some issues. So I called them out here. I mean, one thing is just like, it complicates people watching the system because, you know, okay, does this builder have this much MEV or this builder have that much? When the builder can include the withdrawals, it like really distorts how much, again, MEV is really in the block. And this has nothing to do really with like the execution layer. This is like the fact that there are withdrawals coming from the consensus layer is just this like other thing that's happening and is really distinct from any of this MEV stuff. One thing that happens because of this is that it kind of can mask the actual bids that builders are sending. So like, for example, if I send a payload for like 1 ETH, then you know, another builder could send a payload for half an ETH, right? So it shouldn't win the auction. But if it includes withdrawals for like, you know, say 32 ETH because of validators withdrawing in the same slot, then this bid's basically masked. And there's actually been some analysis. I'd call it the student dashboard here. You can take a look at the doc if you'd like. But essentially, they're having cases where proposers have missed out on MEV they could have gotten because of this withdrawals thing. Another big thing is actually weakened censorship resistance. So there's this min bid flag, which basically says, you know, if I get a mev-boost sort of bid or payload, it should clear some floor. Otherwise, I'm going to build locally, right? And again, this is meant to say, okay, if I have a more valuable block and from the public mempool, I should use that over mev-boost. Again, when you have withdrawals distorting these bid values, this makes this whole thing far more brittle. So generally, there's like big open issues with this. It's pretty easy to fix. We just take the withdrawals out. They're deterministic, so it's like very clear to everyone what they are and how they should be, you know, removed. And that's essentially what this proposal is saying to do. So the way I framed it here is at some epoch, which we could figure out. Essentially, you would just remove the what I'm calling excluded amount, which is just taking this withdrawals to the same recipient that the builder intends to pay. Yeah, so pretty much that's it. Simple change. I also, let's see. I don't have the link, but someone at Flashbots actually already implemented this in the mev-boost relay. So yeah, a few lines change, and I think generally it's like a pretty strong improvement to mev-boost itself. Yeah, Chris, go ahead.
Yeah, thanks for putting this together, Alex. Nice write-up and summary of the whole context. The only change that is needed is a change in the validation code. So the relay is not none of the relay code or deployments would need to change. It's just the validation nodes that would need to account for the withdrawals. And we made a PR that I put in the side chat that does exclude the withdrawals from the block scoring. And Flashbots is supportive, and we would like to find agreement on a given epoch where all the relays start excluding the withdrawals from the bid value calculation.
Great, yeah, and thanks for putting this PR together. That's super helpful. Does anyone, sorry, does anyone think we should not do this? Let's start there. This is your time to pipe up.
Let me ask it as a question. Is there any good reason not to do it?
I don't think so. I think I laid out a pretty good argument in the proposal, which again, it addresses all of these downsides we see. Pretty simple change. And yeah, that's pretty much it. I mean, I think it's pretty clear that the withdrawals really have nothing to do with MEV, so they just shouldn't be there. I think there are more like complicated things we can think about with block scoring, but they have like more edge cases and like, as proposers setting themselves and all this stuff. That stuff is outside the scope of this. And yeah, so pretty straightforward change, I think. And I think pretty clear that it would improve things.
It does require a little bit of social coordination, right? Because like if one relay chooses not to adopt this new scoring rule, then their bids look like they're way higher than everyone else's and they win all those blocks. I guess the coordination mechanism here is like you have to basically have all the proposers agree that that relay kind of lied to them about the true bid value because it included the withdrawals, but yeah.
Right. Well, this is the thing where
it would play out nicely by itself, right? Somebody doesn't do it. We're terrible. We don't do it. And then everybody get ours. And then all the validator will be really mad at us and say like, we're going to disconnect unless you fix it. And then we fix it. So like, even if somebody doesn't play well, all the validators will be very mad, very fast. And then...
But are the validators actually going to disconnect? That's the question, right?
Well, ASIS has already had some pressure from builders to police this, and we've been doing a certain amount of sort of social enforcement anyway. I'm not sure how much of a problem this is currently.
Easy from Lido will come and kick our asses, so like that will be fine. Like that's solved it.
Yeah, it seems like this is a problem that comes with every new builder until a bunch of relays tell them, hey, stop including those. But if we all just set it hard, like by Denku, and just have the new simulation code updated for this, we could probably all be on top of it.
Yeah, sounds good.
Yeah, exactly. So like the withdrawals are deterministic, so it's very clear if this is happening. The bids are all public, so it's very clear again if the builder's doing this, and or a relay is letting it happen. So I don't really see any issues there. Yeah, so that's actually a good suggestion, Ben, to like focus on the Denku epoch. Do people feel okay about that timing wise, that they can get this change implemented in their relay?
Yeah, that sounds fine to me. I do, maybe because now you said, Stokes, like the relays are just letting this happen. I do think it's nice to at least like project the feeling of like relays will not let this kind of thing happen. Like at some point we do something. Just as a
right. I mean, and this is, I think this is the place to do it, right? Because like, regardless of what the builders are doing, the relays are kind of this like validation piece that, should be supporting a variance of mev-boost so that, again, the model makes sense. We can minimize trust guarantees where we have them. And yeah, again, I think this is a pretty clear improvement.
I can agree to that.
Yeah, there's some discussion in the chat around like how many blocks there are. Yeah, Terrence linked this analysis by Data Always. So again, I would point you there. Like ultimately there aren't, this isn't like every block coming through mev-boost has this issue, but it actually is more frequent than you think. And yeah, some builders, so here it says we have Penguin submitting some that, again, we're just using withdrawals. I assume that's from withdrawals, but it sounds kind of high. But either way, yeah, again, this seems like the right place to do it in terms of how we implement it, and seems like a strict benefit to me.
Can I quickly make a suggestion that we have a builder fork or some sort of gist out there for builders to see how to exclude these on their end too, just for these smaller builders? Because I feel like sometimes when you bring this up to people, they have no idea what you're talking about. So if we could just quickly, everyone direct them to the same link that this is what they need to do from now on, I think that would help things too.
Okay, yeah, that's a good point. So there's like pseudocode in the proposal. If that's not clear enough, is there a place you have in mind? Like I would maybe even point them to the Flashbots PR that Chris linked here in their builder repo.
Does that change in the builder code, or is it just in the block validation code?
It's the validation code.
Block validation is in the builder code base.
What was that?
Oh, sorry, let me repeat. It's changed to the validation code, but the validation code lives in the builder code base. So we are using the builder code base for validation. But this
Right,
is the
yeah,
change
we
on the
use it for
PR specifically for
both.
the validation. And we will put out like a patch or a PR for just the changes to the block scoring in the building process.
Okay, cool. Yeah, because I know that the validation code sits outside of the builder logic, right? I mean, it's in the same repo, but as you're building a block and you're calculating the actual value of the block, that's separate from validation code.
Yeah. If a large part of this is just that is the default, it'd be really nice to just change the default that everybody's copying.
Yeah, everyone's using the Flashbots builder, so.
Okay, cool. So let's go ahead and tentatively say, we'll have this rolled up by Denkun. I can update this document that I put together, and I'll follow up to the extent that I can with everyone to make sure we're ready. Great. Okay, 1 second. I'm just finding the agenda. So, cool. The next one I wanted to bring up, well, the next two really are around changes to optimistic relaying. And the context for this was that there were a number of, well, so at least two events, I think, where essentially, again, core devs are watching the protocol. One of the biggest red flags I think that can happen in terms of security and operation of running this stuff is seeing what we're going to call a bad block. So basically, if I have a node of the network, if I get a block from a peer, if the block is bad in some sense, which again essentially means invalid, then yeah, this is not good. It usually raises a lot of big flags in the logs, and I think all the client teams have alerting and stuff in place for this, so it becomes very clear to them very quickly when this happens. And ultimately, the reason this is bad is if there was a block that got into the chain that was invalid, especially for example with the geth dominance we have, if there's a geth bug that accepts this block when it should not be, the validators then finalize it. We now have basically finalized a valid chain, and this is very, very bad. It's very, very bad because we'd essentially need to either agree that this is now the protocol, which is not a road we want to go down, or we would have to roll back the block somehow, right? This would be a DAO hack level scenario. So generally when this happens, it's not good. And luckily in both these cases, the clients all found these blocks as bad or invalid. So, they're working as they expect. However, we really, ideally everyone's a good citizen on the peer-to-peer network, and this is not even happening in the first place. It being the fact that, these blocks should never even be gossiped, right? And as far as I can tell, at least in one case, what happened was essentially with optimistic relaying, there was a bug in the validation code. So I think in one case, what happened was basically the builder should have been demoted, but it wasn't. And then the blocks basically, the first block got through in the optimistic relaying model. This can happen once the builder is demoted. The slot would be in, it's a missed slot, the block's invalid, okay. The proposer should be compensated from the builder's collateral, everything's good. In this case, there was a bug, and so we actually got multiple of these bad blocks through. And yeah, that's not great. So what can we do about this? One thing we can start to do, and this is again more of a discussion point, but the suggestion is essentially, if you're in optimistic mode, essentially don't release the payload until you validated it locally. As far as I understand, relays today, they will eventually validate the block, but it might not be before they release the payload. For example, to their local consensus clients even. And so the change here would be to basically say, okay, regardless of all optimistic bid serving and all of this, you actually block on payload release until it's valid. I'll stop there, I guess. Does everyone understand what I mean, or should I go into this a little bit more?
I understand, but that seems like you could then spam the relay with a bunch of blocks to basically force a missed slot. If you're a builder, you just send a bunch of fill up the validation queue with whatever, and then that's gonna delay the block publish.
For example, and like the thing, like I don't even think this was like sort of a malicious scenario. It was just like a bug. There was an accident, and so we still got to the same outcome. And like in either case, I think it makes sense to actually block payload release. And you know, the slot could still be missed, even if there is a bug. You know, for at least one slot, you could still have a missed slot, and builders demoted in all of this. However, this is more of like a network health thing where like the relay should be a good actor here and they shouldn't even be like putting bad blocks out in the first place.
Yeah, and maybe also like if people are worried about the scenario where we get like maliciously attacked in such a way where we sort of overflow and the relay just can't handle it anymore, and that's why we're not publishing. I did a quick look for Alex Stokes at how often it is the case that our ultrasound relay still has time. And I think it was something like 8.3% of blocks we would not have time to simulate a block before we need to publish it, but all the rest we do. So you could even see this as an optimistic scenario where in, I guess that is then 92% of cases, you are able to simulate that block. You are able to see that it's invalid. You are able to then decide not to publish it because you know this block is invalid already. So that could be a pretty nice way really to improve their safety.
Right. Yeah.
I want to offer, it's not that I disagree, but I want to offer a counter argument, which is I think we're going to cause more missed blocks by simulating the block. So that, like just using Alex's numbers, in 8% of the cases, you're not going to make it in time. So like you don't have enough time. And if some blocks actually sometimes take longer to simulate, then potentially we're going to induce more missed blocks by holding it off and not releasing the payload. So I'm not saying not to, I'm just like, there is also the downside of it. So we're going to have, it's going to increase the latency. And so therefore it's going to affect that. Potentially, yeah, stopping here.
Kubi, you had your hand raised for a bit.
Yeah, just a bit of a clarification. So it was my understanding that the error was in the validation code itself. So in this case, if you, it wasn't. I'm just seeing Nicholas shaking his head.
I thought it was the demotions, but you know it was.
Yeah, I can clarify really quick.
Yeah.
The error was in the demotion logic. So the validation code was returning an error, but the demotion logic, there's a couple of scenarios where there's like a false positive that doesn't necessarily mean it was bad. It was just, it could have been chain state issues with one of the simulation nodes that was simulating the block. In this case, we were treating something that was a true error as a false positive, which was working fine for months, you know, and then this one came through and it caused a lot of issues. So anyway, the bug was in the demotion logic. We've since went a lot more strict in demotion logic, and I'm constantly clearing out false positives every like 30 minutes right now. But it's just an issue on the demotion logic. In terms of actually simulating the block before you return the payload, there is some benefit to that, and I think we could actually do that right after returning a header. You have some latency between the time you've returned a header to the time you get a get payload request, anyways. And there is some ways you can make sure that that request is from the validator, so you're not just simulating like 1,000 blocks, because I mean we get like 1,000 get header requests every slot, but there are some ways to identify the validator with that. And it's also another good reason why we might want to consider having validators sign get header requests, so we can know that that was them and then allocate resources for those more intentionally.
Okay, thanks. Yeah, so I guess my initial thinking was if there was a problem with the validation logic, then this obviously won't solve it, but that's fine then. I would still have similar concerns to Yuri. So this will probably lead to us or a general there being more missed slots than before. Yeah, that would be my take, so, or my fear.
Missed slots just because the block isn't sent out on time.
Yeah, because of additional latency.
Yeah,
Right.
I think Ben can add more insight to it. Like the reason the bug in the demotion was this, the simulation takes a lot of time. Okay, we think it's okay. So I think like the bug was in seeing a timeout and kind of like, well, the timeout doesn't mean that it's invalid. Well, it actually was invalid. So the problem is that if a block takes a long time to simulate and we don't know in advance how long, maybe it will be a long block, maybe it will be a short block, then we'll have more missed slots.
Yeah, I feel like, I don't know, but there's a general agreement that it maybe doesn't make that much sense for a relay to like block and to like go simulate the block and then not publish until it has simulated. Like I totally agree there. I think for me at least, more the observation was that relays often, as Ben just suggested, do have time from the point that they've served the header to the proposer, which they know is likely to be picked, to then just go simulate the block. And if you then notice that it is improper before you get the signature from the proposer, you do have the ability to just say, okay, let's not even try. And then in this case, like again, if it's a demotion bug, there's no help there. But there may be cases where a builder submits an invalid block that turns out to be a wrong block, and now the relay just has time to notice that it's a wrong block. And then by the time it gets the signature, it says, oh, wait a minute, you know, the header I served, I can never publish this. Like, I'm not even going to try.
Yeah, Murat.
Right, but
would it be appropriate to suggest an alternative for the solution? So instead of withholding the payload, the relay could encrypt the payload and release it as it does today, but send over the decryption key when it's validated. And this could alleviate some of the latency problems as the payload size is much lower. So just wanted to kind of pose that. I guess the proposer would, right? So that's also an operation, but that might be much faster than waiting for the payload.
Well, so the relay also gossips the block and it needs to do the same thing. So yeah, I don't exactly see how encryption helps much there.
Well, the payload would be there, right? It would just basically that we reduce the latency surface to decrypting the payload rather than sending over the payload. Or I guess sending over the decryption key and decrypting the payload rather than sending over the payload. It should shave off latency theoretically.
It kind of resembles the original architecture of BlockStart, etc., where we were like, this was my original idea regarding scale whatnot, etc. In reality, it adds a lot of complexity of this kind of, okay, let's send it and then decrypt it afterwards. Like the complexity around it is very, very high. The latency savings probably not as high.
I see. Okay.
Well, there also is latency to this encryption decryption process, right? So I think relays and builders are generally optimizing for things about on the timeline of the encryption. So yeah, I don't see how this helps too much.
Well, it would be much faster.
Also keep in mind that block is actually usually published through the relay and not through the proposer. So the latency of sending the payload to the proposer is not impacting the proposal time because it's already going out through the relay and they're well cleared CL clients.
So the largest latency impact is between the builder and the relay is what you're pointing out. Okay.
Yeah, exactly. And the get header and get payload request latency between proposer and relay, but not the response from get payload. That is already irrelevant at that point because concurrently the block is already getting proposed and getting
makes sense.
Published.
Yeah, Mike.
Yeah, I guess my main thing that I feel now is that we're kind of getting into the nitty gritty of how an optimistic relay is implemented. And there's just like, we can talk about what went wrong and stuff, but like these things are going to be continually evolving. And like, I think bugs will continue continue to happen, and like it just almost feels inevitable that when there's like a small set of people producing all the blocks and a small set of relays publishing those blocks, like bad blocks are going to hit. And like if these norms that we're trying to codify add latency, then like the relay or builder that violates that norm is going to have like a latency advantage, right? So I don't know. I don't know exactly what the point I'm trying to make here is beyond like, I think these problems will probably continue.
Right. And so I think this proposal is kind of like defense in depth from my end, where it's like saying, hey, there will be bugs and we should make sure there are not bugs, but that can happen in parallel to, checking where we can. Okay. I was actually about to circle around to Alex's point, but there's a message here. So you think that was not a helpful suggestion?
Yeah, I don't think it helps that much. Like, as I say in the message, like if it's the same slot, a relay may notice, and by the time it gets the signature, refuse to publish. Which could be helpful in some cases, but we're missing the slot anyway at that point. And for the next slot, a demotion should happen, and then if the demotion has happened, then again it's not a risk anymore. So it's really only that very first slot where you notice the builder has made a mistake, give you an invalid block, and you've already served the header for it. And then noticing that the block is invalid, I only see that you can keep the network from forking by some clients still accepting that publish and others rejecting it. But there I feel like we're going a bit far. Like, could be an interesting conversation, but I think we're pretty far beyond what a relay is trying to do, and much more deeper into client consensus client execution client responsibilities.
Sure. But what happens when there's a bug in the demotion logic and this is now like 9 slots, which is where this came from?
Yeah, but then I think isn't it the demotion logic? Yeah, okay. But then you would miss still every slot, right? Like every slot, the relay might notice that, hey, this is a block I cannot publish. It wouldn't publish it, but how would the relay know in time?
Right, because if we're assuming there's a bug in the demotion logic, then you're kind of screwed. Ben?
Yeah, so like basically, if we try to simulate the block before responding or publishing with the payload, we could still miss the slot because of the delay on that. But also, if it's an invalid block, we'd miss the slot anyway. Whereas, assuming demotion logic is correct, we'd miss one slot regardless, right? So we wouldn't really save anything if we're simulating beforehand. But a couple of ideas about improving demotion, because right now the risk is per optimistic builder pub key per relay. So like we could be publishing a block, ultrasound then publishes a block for the same builder that has the same bug, and then that's 2. And then it's like there's 6 pub keys that across there. So one idea that I think would be nice is for optimistic relays to expose some sort of endpoint or service or WebSocket or something where they are informing the other relay that they're demoting a builder. Something along those lines, so we can kind of have better protection.
Yeah, I'd love to add to that if I can. I don't know, Terrence, if that's okay.
Sure, go for it.
So what we're working on also is in-block demotion right now. So we're trying to make it possible for a relay to notice just as the submissions are happening that one is invalid and immediately demote a builder so that they may not even get to be the top bid that we serve. So we could potentially even help also other relays to then, never serve a header if they quickly enough get the message from us that we're noticing in this slot that this builder is doing invalid stuff and they should be getting demoted.
Yeah, the other thing too is grouping builder pub keys, because most builders have sets of builders that are running the same version across different regions, where maybe builder 1 and builder 2 are completely different builders. So a bug that's affecting builder 1 wouldn't affect builder 2. So I've talked to a couple of builder sets about this, and they're wanting to do groupings for demotion to limit their risk as well. So there's a lot to improve on that.
Terrence, you've had your hand raised for a minute.
Yeah, sure. So I guess like from my perspective, from the client dev, I think missing one block due to optimistic relaying is fine, but the issue is that we're missing multiple blocks. And I guess that typically happens because of the demotion logic fails. And has anyone thought about solving this issue from like an mev-boost or the client implementations perspective? For example, like some idea I can throw out is that we can have like a relayer monitoring system that is just centralized, but then as long as say like there's one relayer that has like an issue that relays the invalid block, we just shuts off that relayer, right? And that's probably not a good idea because it's like we are trusting someone else for something. Again, and I guess like a trusted solution of that would be like a P2P Gaussian network that if today there is like a relayer Gaussian, sorry, there's a relayer that is relaying a invalid block, you have like a P2P like fraud proof style thing that it goes into the rest of the proposer, and then the proposer disconnect with that relayer. I guess these are some other solution space, but they are mostly on the proposer side.
Right. Yeah. So Francesco actually had a really nice proposal to basically add something like a bid mempool that starts to get at this. I don't know if anyone's had a chance to look at it here, but essentially, yeah, it would start to help us like have this more like decentralized observability around what the relays are doing, and that could definitely help. So there's that. This is maybe slightly out of scope for this call, but the idea also came up on one of the all-core devs calls to basically say, so clients today do have circuit breakers for various conditions to just not use mev-boost at all. And this could be one as well. If they see like a bunch of bad blocks, just like stop for, you know, some time. Yeah. So yeah, this kind of takes me to the next point, which is just like increasing legibility, I suppose, around optimistic relaying generally. Like even right now, I think it's very hard for people to know like which relays are optimistic, like which builders are registered, and all of this stuff. I think ultimately, you know, like one really nice solution here is basically moving everything on chain. I don't know how people feel about that. It probably needs a little more specification. Sorry, but yeah, this is something to start getting on our radars. I don't know if any relays have thoughts about that, like essentially making optimistic relaying more transparent.
I mean, as far as I can tell, optimistic relaying, at least for the ultrasound relay, is maximally transparent in the sense that for every single block, we'll tell you whether or not it was processed optimistically. There's a is optimistic flag. I think that's part of the default flashbot implementation as well. So I expect the other optimistic relays to also support this API endpoint. And this API endpoint, for example, is used to power some dashboards. So if you go to mev-boost.pix, it will tell you high-level stats like what percentage of blocks are optimistic, which builders are using optimistic, blah, blah, blah.
Great. So yeah, I mean, maybe it's just leveraging that information a bit better. Okay, so to summarize a bit, there is this proposal to essentially block payload release. It sounds like we generally don't like that here. Am I reading the room correctly? Getting some nods and thumbs up. Yeah, the implications on like timing games, and then also, yeah, like the converse of having more missed slots is not great. So I think it's definitely a little more complicated than yeah, just withholding payloads until they're validated. And yeah, so maybe the next bit was, yeah, just around transparency in general. Someone has something to say?
I wanted to ask, and maybe it's a stupid thought, but does it make sense that in addition to the simulation of a block, I'm very much against like doing a block while simulating, etc. But does it make sense to make it more robust? All the relays run blocks, validators anyway. If we see kind of like, yeah, we're going to do the simulation and everything, etc., but have another source of truth if any of our nodes see the block and reject it, okay, tell it to demote. So basically making the demotion mechanism more robust. So it both checks it internally with all the checks that we want to do, etc., but also a bit of a black box. Use our nodes out there. If the node says it's wrong, then we have an issue. And it might cause some false positives of kind of like, okay, like demoting, etc., but that seems like a small chance and a low risk. Maybe it's stupid, maybe it doesn't make sense. I'm kind of just jamming or speedballing here.
Which other nodes do you mean?
Like we run multiple nodes and we use them for a bunch of stuff, including simulation. These nodes not only help with the simulation, will also literally eventually they'll get the block and try to include them. If they reject the block, then it's kind of like it's another source of truth. Maybe and we have a bunch of them, and obviously we give them the new blocks anyway. So just get like another read from them that they accepted the blocks. But maybe again, Ben, do you have any insight on this?
I mean, it's the same thing, right? I mean, ideally the demotion logic works at that point. So if as long as the demotion logic's good, any point of failure along publishing a block will have issues. We'll take care of it. So really the only major issue of this was demotion logic, not so much a protocol issue or an optimistic issue. It's more just that demotion logic wasn't working properly.
Right. Which also kind of brings up the next suggestion, which is in some sense having like almost like fraud proofs gossiped amongst relays. Seems like there was more appetite for this. Do we like this?
Yeah, I mean, I'd love to have more cross relay communication going on. I think I suggested something a long time ago about some relay P2P going on. But it was just back then there was really kind of no reason to do it. Now we're getting to more use cases of why that would make sense.
Right. Yeah. Alex?
Yeah, pretty strongly in favor for the good of all the out of protocol block building ecosystem. Also, maybe in general to add, we already in our relay have several actually circuit breakers, and they also have tripped at times. I do again agree with Ben that you want to be very wary of just make this core demotion thing work, because that's very, very critical. I think that's a first, but I do think for relays in general, it makes sense to have, as Yuri suggested, sometimes a mechanism that says, well, if this really strange thing goes wrong, like I've served 3 headers and I expected them to go on chain because I was publishing blocks for them, but then none of them appeared, to have at least an alert. And we have various phone calls and various circuit breakers where our auction will just stop serving headers to try and make sure it doesn't do any more damage, something like that. And then this relays working together to make that even more effective, I think is a great idea.
Yeah, definitely agree.
Oh, I guess when we're on that topic anyway, I have been working on demotions recently, like and changing some things also from we had a very close copy of the Flashbot code, and then now we've changed it a little bit. Especially in scenarios where there was many submissions which were invalid, we saw like some strangeness happening. So I guess if you're working on demotions in general, then yeah, happy to talk about making that more robust or something like that. I did already check the Flashbots code, and that does, I think, yeah, that I am pretty sure has all the changes sort of that I made on our side to make it more robust.
Just one quick side comment on sharing potentially demotions across different relays. This also means if one relay has a bug and wrongly demotes the builder, and this has happened, for example, when we have tested stuff on testnets and other kinds of scenarios, we're basically just demoting that builder across the board.
Yeah, I think we'll have to figure it out, but what I feel like would be a good solution is not just gossiping like a builder pub key, but also the payload, so that a relay could simulate that payload themselves to verify that that payload was invalid, improperly built, so they can do their own checks on there to decide to demote that builder, not just spamming demote every builder.
Yeah, I think the builder would kind of have to opt into this though, because I know, I mean, we are builder as well, but we don't submit to every relay, and so because there are obviously some trust assumptions there. So if you're actually gossiping the payload, that has to be okayed by the builder.
Terrence?
Wouldn't it make sense to have the validator also monitor this P2P network? Because the builder's public key is known through the header's bid, right? So if a validator, I monitor this network, I see this builder's bid is, or this builder's key is getting gossip among the relayer that it may be demoted. From my end, the validator side, I could also kind of just like make my own like action, make my own and make my own decisions, such that I don't have to rely on what the relayer does. I think it may be more trustless this way. No,
So the mev-boost only sees the relay's pub key and not the builder's pub key, which is something we could change, but you wouldn't be able to do that.
Really quick, because Kubi brought up that we'd be gossiping payloads from builders. Those payloads would already be attempted to be published anyways, so there's not really any privacy guarantees of any transactions in a published payload anyway. So if we were doing demotion logic, so after a block had been attempted to be published, we found that it was a bad block that really demoted them. There's no guarantees of privacy for any transactions in there because they've already been attempted to be gossiped across the network anyway.
Yeah, that's a good point.
But couldn't you just then unbundle the block and no one knows which relay it was?
What was that?
Wouldn't it then be possible to just unbundle the block and no one knows which relay's fault it was?
But allegedly the block's already out there, right? Like this would be the scenario where it's like I'm trying to publish and then there's some failure. So this is Ben's point that the block's already out there.
I see. Makes sense.
Yeah, Terrence, just to close the loop there, that's actually the relay's pub key, and the specs are a little confusing here. The way the specs are written is that essentially it's, yeah, like it's when it says builder, it's like abstractly a builder just with respect to mev-boost. But yeah, this is actually confusion that keeps coming up, and honestly, me or someone should go change the specs so it's more clear what's happening. But this is my other point, is that, in this builder bid, even the spec thing that you put in the chat, like you could put, so the pub key there is a relay's pub key, but you could very easily also have the builder's pub key if we need it for this reason. Any more to say on this topic?
If people want to do a POC with us on this relay gossiping, please reach out. This is very interesting for us, and we'll probably quickly enable this on Holsky next week or something, just to see what it looks like.
My one last point is I know that some people are running ref block validation code. I think there's an open source fork out there somewhere. Does anyone have any like performance metrics on that to see how fast that is? I'm sure it's faster than Go, but want to see some data if that's available. Don't say that.
One more time, performance metrics on what exactly?
if the ref block validated code outperforms Geth.
Yep,
Right.
Flash also tried it out, and in our experiments, the Geth validation code base was faster than the ref one.
Oh man, someone needs to post that in the ref Telegram group, and they'll fix it.
We've already talked to them about it. We've
Yeah.
done a few iterations on staging. It's about the same as a get. So we kind of put it, it's not important, not a priority currently. Was hoping to get some easy gains, but nowhere to be had.
I know. It's
Yeah,
like,
and we have
like
a
10
public-
millisecond simulation time. That'd be great.
Right. We have a public repo for that as well. And I think last I checked our conversation with the ref team, we gave them some frame graphs, but I don't think we continued after that. Like Nicholas said, it wasn't a priority for us.
I am more than happy to reinvigorate that conversation.
There we go.
I mean, I'm here listening.
Love it.
Cool. Chris, you had some questions in the chat. I don't know if you wanted to run through those.
Yeah, sure. One question was about the optimistic relaying code path in the mev-boost relay code base. Flashbots is not maintaining that code path, and I just wanted to double check whether there's any changes expected for the net, or if it's basically like the net ready as is. Because some relays, I think Astas and Agnostic are using that, if I'm not mistaken. I don't know, Mike or Alex, you have any insights? All right. Max, you're here from Astos, right? Have you used the relay with optimistic relaying?
We do with some changes. I need to go and have a look at it. I'll come back to you on that.
Okay.
We've done a bunch of change. We've done a bunch of testing on Gali and on Holchki. So I think we're good to go. But let me come back to you.
Okay, that sounds good. Yeah, please post a note in the relays group somewhere or in the forum. Somebody tell Agnostic that they should also double check. Flashbots does not provide any guarantees about the optimistic code path. We're not running it, and we're not, just to be clear, we are not maintaining that code path, just the regular non-optimistic one. Okay, that was one. Yeah, thanks. Then I heard that ultrasound, you guys saw some 2.2 errors from the CL client when publishing blogs, and would be really curious about a little bit more details and if there was any insights you had.
Sure. Yeah, I'm afraid I'll have to disappoint, but like just what I noticed is that sometimes when we try and publish blocks with Lighthouse at 4.6.0 and the latest version of the Flashbox mev-boost relay, the payload API that's in there, sometimes both nodes would indicate the 202 status code, and then that's seen as a failure, and the relay treats it as a failure scenario, logs an error, and also like doesn't progress on the success path where it would reveal the payload, right? And then when I started digging into it, I noticed that Lighthouse gives a 202 also when it sees that the block is already known to it, it's already a part of the chain, and therefore it cannot publish it. So initially I suggested maybe we could just make that a warning, scary error goes away, and also like our errors become a high signal again. The difficulty there is like the more I was reading about it, the more I started noticing that I think there's also a scenario here where the block is invalid. I found a buried issue somewhere. So like, yeah, if somebody goes to look into that, you need to be very careful that I think the 202 can be a hacking scenario where the block is judged to be invalid, but recognized, but I'm not sure. And then this was costing a lot of time. So then I said, okay, I'm going to leave it for now. So yeah, I'm not sure there, but if somebody wants to collaborate on it maybe or something, I'm happy to provide more context and collaborate. Does that answer your question?
Yeah, thanks for your insight so far. Ben, you have something to add here?
Yeah, we see 202 a lot with publishing blocks. The way we publish blocks, we do it to a couple different things. Like we push to our BDN alongside our a couple of CL nodes as well. And we see that pretty much the first server that sees it will get a 200 code response. Then everything else will probably be a 202. So it's basically after it's seen it from another P2P, I guess, channel on there, then it doesn't necessarily mean you're going to get a 200 response, but
All right, thanks. I think that clears it up so far. The last point that I was wondering about is, does the ultrasound relay add like delays to push get header responses until like to postpone that until a certain point in time?
Yeah. So what we do is we do try to use the time that we think is available to try and get the highest possible bid to give to the proposer. But of course, also respecting the delays that we see. So there's the delays to client side that we have to take into account, and then there's further like delays where it just gets dangerous and the block might not make it anymore. So we might not give you a header at all anymore if we see that there's very, very little time. But there's basically where we give no header anymore, where we're like almost immediately replying, and where there's still a lot of time, we think. So we wait a little bit longer to try and get you a better bid.
And is that in a public code base, or is that in a that's like get header changes, right? Like, are you running a customized?
Yeah. The logic for that is generally private, and also I think some of that will be what gives us an advantage, which may make us help to make the relay as sustainable. But we are like generally open to questions, and although the specific timings, of course, might be sensitive and we might not want to reveal, generally what we're doing, we're happy to be open about and give some insights into. So yeah, do feel free to ask more specific questions, and I'll just try to answer.
Yeah, I wanted to say, like, if they didn't, our percent of winning would be even higher. For real.
Right. I
So
mean, there is a race to zero, and you know, in some sense, we're kind of following what Blockstrom possibly started. And now basically the game is to delay as much as possible with whatever budget mev-boost gives us.
Maybe worth mentioning here what we're doing with our validator gateway. I don't know if we started the game. Like, I think it was P2P who started the game. But like, I don't think we started it. But from our perspective, with our validator gateway, for those who aren't familiar, basically we take a node, it sits really close to the validator, and instead of playing the best effort game in which the validator asks all the relay but have like a threshold, okay, I'll wait up until, let's say, 900 milliseconds, then we tell the validator, tell us exactly when you define it to be a good time from your perspective. We'll give you a block exactly at that time. And so this isn't timing game. This is like, if you're waiting for others anyway, we'll wait to that. If you want to get that at time 0, we'll give it to you at time 0. If you want it at 100 millisecond, we'll give it 100 millisecond. If you want it at 15, a second and a half, 1500 millisecond, it is the validator decision. But the idea is that currently, if you just send it to all the relays, we found that we underperform because we're faster. So somebody asks us for a result, we immediately give it back. Voila. Ultrasound, if it's a validator in the US, ultrasound has like 100 milliseconds just until they hear the request. They'll beat us and provide a better header. Well, we could have waited 200 milliseconds. Like, we should have had an advantage in waiting until ultrasound have responded. So we see the validator gateway as a way to get around it. And instead of being like best effort to just, everybody try to be as fast as possible. But here's the threshold that we consider safe. Just tell us exactly when you want the header. We'll give you the header at that time.
I'd like to also mention one point of the validator gateway is to not encourage co-location with relays. Like, we set it up in a way that it runs near validators where they want to run. And we're actually working with validators that are in low performing regions that have stakeholders almost demanding them to move to either the US or the EU so that they can have better performance. And we are seeing a really good increase in their performance for their consensus layer rewards, alongside with the relay proxy seeing some good performance with them with get headers. Because historically they time out at 950 milliseconds because of this latency from people like in Africa trying to make a request to a node over in the US. It's a long time. So it's been really good to see that we're fighting co-location with us.
Matt, did you have something to say? Maybe not. Yeah, Marat?
Could there be an avenue for other improvement proposals? And this goes back to this kind of mev-boost modules concept that I had pitched in the first meeting at DevCon Bogota. So and because lots of folks are working on stuff like this, and you see like validators saying, look, we're not that technically sophisticated to like do all sorts of things. So if there could be an easy way to modify or create modules for mev-boost that can add some logic to the commitment, I believe it would unlock a big design space for lots of people.
Yeah, we do see that most validators don't want to modify mev-boost. Everyone wants to be vanilla because no one wants to maintain a fork of a constantly updated code base. So yeah, there's something that could be more modular. I feel like validators would love that. But validators see the APY improvements for Kiln or P2P or any of these people that are waiting massive delays, and they want that. So the market's pushing for it.
Would the group be open to like working on a proposal where we can have a framework that, like, I don't want to name it an app store, but you could have a thing inside mev-boost and people can plug and play and build things there. So that could be a major feature for this piece of software, in my opinion.
I guess we could think about doing like an experimental mev-boost release, mev-boost version. I don't think we will implement that complexity in the stock mev-boost software because on my experience working on it, it's just really tough hardening the software, and it's immediately shipped out to hundreds of thousands of validators that lose money on bugs. And it's really scary. And like every bit of complexity is already a big hassle. I don't see that type of complexity making its way into the regular stock mev-boost release. But I guess we could brainstorm on how to enable like an experimental branch or fork or something else. That's my intuitive take.
Yeah, I appreciate that, Chris. And maybe this goes into the design of it, right? Maybe it's better that the relays absorb this complexity or something. But this general idea of kind of mev-boost modules, wherever it sits, I do believe would unlock many things for the ecosystem.
Do you have some examples of these modules?
Yeah. So, there's a Tyco pre-confirmation proposal, and we're doing pre-confirmations on mev commit as well. So we're looking to have validators opt into this. Now, there's many methods where you can do this. They can use some staking token, or they could say, hey, look, relay, you take care of this, and I'll pay you a fee. Or they can modify mev-boost, right? So the logic would be that basically I have some pre-confirmations as a PBS actor, whether you're a builder, relay, or validator, and I'd like these to be, I'd like this game to be played in the set of bids that are coming to my validator, right? So the validator makes some preference that, hey, this is the type of game that I want to be played, and presumably the relay or the builder is playing that game, and that there can be some harmony across the pipeline on whatever that game is, right? And I'm kind of putting out this module store as a place where you can kind of pick and choose your games. Maybe there are timing games, maybe there are other new games, but that's kind of how I imagine the validator would kind of communicate with the rest of the pipeline when it comes to their preferences on the games.
Yeah, I mean, this sounds like something that relays would offer, right? Like you could imagine different relays have these like value-added services, for example, that could do that there. I generally agree with Chris and others that like mev-boost itself should be as simple as possible.
Yeah, then the question becomes, how do we kind of link that to the protocol, right? We can have the validator kind of opt in some other method, but what I'm seeing in the community, particularly when it comes to some of the proposals open with Tyco, et cetera, is that people are suggesting that they build a new mev-boost fork, et cetera. So it's more of an observation that the ecosystem is doing these things, and it looks like this group has some insights that, you know, we shouldn't do that because it adds complexity, it's difficult, et cetera. So maybe this is just a starting point on thinking about this, and we'll arrive at something more concrete.
Yeah, do you have a link to the Tyco discussions? Like if they have a forum or something?
Yes, well, there's a proposal by Nethermind, I believe, and they talk about this. I will link it right now. And I saw this from like DVT Tech, like OBOL, et cetera, where they have some logic that they want to put. I'm not particularly suggesting that that goes into mev-boost as well, but it seems like the ecosystem is there's emerging many different types of commitment logic for proposers, and this could be an avenue where that can surface.
Yeah, thanks for sharing. Anything else? Anyone wants to discuss? Okay. Sounds like that's that. Hopefully this was a helpful call for everyone. If you are listening or here, go get ready for Denkun. It is happening very soon, and that should be your top priority. And yeah, otherwise, thanks for joining everyone, and I'll see you later.
Thank you, everybody.
Ciao.
Bye, everyone.